So today we're going to practice solving quadratics with square roots. Now quadratics just means that we're going to see an x squared there. Solving means we're going to get x by itself. So when we see an x squared, there's a few things we have to take into consideration. When we solve with square roots, we have to make sure that my x squared is by itself and that it equals a positive number. So I want my x squared to be by itself first, and then make sure that it equals a positive number. And these things are important because if it doesn't equal a positive number, we'll see what happens to our answer. And if x squared is not by itself, we can't take the square root of it first. So in order for me to solve an x squared, a quadratic function, I need to be able to undo this squared. And how do I undo something that's squared? Well, the opposite of x squared is taking the square root of x. So if I take the square root of x squared, that will leave me with x alone, and that's how I cancel. So the square root and something squared, these are inverse operations. These are opposite operations, and this is how I undo. So whenever you see an x squared by itself, you can take the square root of it to undo that operation. Okay, and remember, these are your perfect squares. This is a list of your perfect squares. And we like perfect squares because that means I can simplify them if they're underneath the radical sign. These perfect squares. Okay, so let's try one together. Let's look at number 1. X squared equals 169. Well, first let's make sure. Is x squared by itself on this side of the equal sign? Absolutely. And does it equal a positive number? Absolutely. So what I can do is I can take the square root of both sides, so that on this side of the equation, you're left with x. The square root of x squared is just x. That cancels. Good, now we have x by itself equals the square root of 169. Now what is the square root of 169? Well, let's see if it appears on our list. Is this a perfect square, 169? It absolutely is. And what number times itself gives us 169? The square root of 169 is 13. Awesome. So now x equals 13. And when we solve quadratics, we need to make sure that we indicate that that 13 can either be positive 13 times positive 13 or negative 13 times negative 13. So both of these answers we need to write. So x equals positive or negative 13. Okay. Let's try again. X squared equals 63. So x squared is by itself. That's great. It equals a positive number. I can take the square root of both sides. So let's go ahead and take the square root of both sides. The square root of x squared, these cancel out, leaves me with just x, equals the square root of 63. Now 63 is not on our list. It's not a perfect square. So now I have to see if I can reduce this radical, which you guys have practiced already. So let's see if I can reduce this radical. 63. Are there two numbers that multiply to 63? And I want one of those numbers to be on this perfect squares list. Let's see. Well, 9 goes into 63. 9 times 7. 9 times 7 is 63, and 9 is a perfect square. So I want to find two numbers that multiply to 63. I want one of those numbers to be the biggest perfect square. Awesome. Now I could take the square root of 9, which is positive or negative 3. Remember your positive or negative. And then the square root of 7 is just the square root of 7. That doesn't reduce. So x equals 3, positive or negative 3, root 7. Let's look at number 3. What's different about this one? In number 3 here, x squared equals a negative number. So x squared can never equal a negative number because that can't ever happen in real life. No number times itself can give me a negative number. So when you have x squared by itself equaling a negative number, you write no solution. No real numbers equal that answer, so no solution. Okay, and that's it. That's all you have to do for that problem. For number 4, let's look at number 4. X squared is not by itself at this point, so you know how to get x squared by itself. Ask yourself what things are bothering that x squared. Well, that plus 8 is, so I'm going to minus 8 from both sides to get rid of it, leaving with x squared equals 20 minus 8 is 20. Now x squared is by itself, so you can take the square root of both sides. Square root square root. And same thing here, the square root of x squared, that cancels, leaves me with just an x equals the square root of 20. Now, is 20 on my perfect squares list? No, it's not. But let's see if I can reduce it. What two numbers multiply to 20? I want one of those numbers to be on that perfect squares list. And if you're not sure, this is a very okay time to take out your calculator and start guessing and checking. If you said 4 and 5, you are absolutely right. So the square root of 4 times the square root of 5 will give us the square root of 20. And now we can solve. So x equals, what's the square root of 4? Positive or negative 2. And the square root of 5 does not reduce. So my answer is x equals positive or negative 2 root 5. Fantastic. Okay, you guys are doing great. So when x squared is not by itself, you have to get rid of it, rid of anything that's bothering it before you take the square root. Let's look at number 6. So for number 7. Let's look at number 7. X squared is not by itself, so I want to get rid of that. Divide both sides by 25. Now I have x squared equals 4 over 25. It is really important that you guys leave your answer as fractions. Don't convert it to decimals, just leave it as a fraction. Now because x squared is by itself, I could take the square root of both sides. That cancels out, gives me an x equals the square root of 4 over 25. Now check out how I can write this. I can write this to have that square root sign being over both the numerator and the denominator, which works out nice because 4 and 25 are both perfect squares. So x equals the square root of 4 is 2. The square root of 25 is 5. And remember that plus or minus part in the front. And just to recall, when you take the square root of a number, you take that square root sign away. So square root of 25 becomes 5, not root 5, just 5. Take the square root, take the square root sign away. Fantastic. So let's look at one like number 9. In this case here, I'll just talk you through it, just a little bit of it. In this case here, your gut tells you to distribute that negative 2 to both sides. And you can absolutely do that. You can distribute that negative 2 and then solve. Remember that your 0, for this one I highly recommend put that line down. And anytime that 0 is there, just write that 0 on the other side. So 0 equals negative 2x squared plus 80. And then you'll minus 80 from both sides. Negative 2x squared equals negative 80. And now you can divide both sides by negative 2 to get x squared is 40. And now since x squared is by itself, now I'm allowed to take the square root. And the square root of 40, now that's not a perfect square. It doesn't appear on my perfect squares list, 40. So I need to find two numbers that multiply to 40. I want one of them to be on this perfect squares list. If you guessed 4 and 10, you're absolutely right. The square root of 4 is positive or negative 2. The square root of 10 doesn't simplify, so that stays the square root of 10. Just be careful for ones like 10 and 11. You have multiple variables. You have common variables on both sides. So you have an x squared here and x squared here. Just make sure you bring those first together. Okay? So you have x squared minus 13 equals 15. Bring your x squareds together by using opposite operations, and then you can solve. Okay, perfect. Anytime that you are able to distribute, anytime that you see a number or a letter in front of the parenthesis, you can absolutely distribute. Remember, when you have terms on the same side that are common, you can combine your like terms. So let's look at ones like 14 and 15. So 14 and 15, the directions are solve for the indicated variable. When you say solve, that just means use opposite operations to get the variable by itself. So let's practice with number 15 here, since that has a fraction. We'll practice that one together. So 15, I want to get t by itself. Right now, this t is being bothered by the squared, it's being bothered by an a, and being bothered by a 1/2. I'm not allowed to get rid of that squared first, because the only time that I can get rid of that squared is when I see t squared equals a positive number. And I don't see that yet. T squared is not by itself. So my goal is to get this t squared by itself first, and then I can take the square root. So what things are bothering that t squared? Well, that 1/2 and that a are bothering it. And what operation is bothering those variables and numbers? Multiplication. So I'm going to divide by 1/2, and I'll divide by a to get my t squared by itself. And on this side, I'll divide by 1/2 and divide by a to get my t squared by itself. So on this side of the equation, I have d over 1/2 times a equals, and on this side, I just have t squared. Let's clean this up a little bit. We know that dividing by 1/2 is actually the same, dividing by 1/2 is the same as multiplying by 2 over 1. So instead of dividing by 1/2 here, I'm going to take my fraction, which is d over a, and I'll multiply it by 2 over 1. That just looks more neat, and in mathematics, we don't write fractions in the denominator. Good, and this side still stays the same. I haven't done anything with that yet. We can clean this up a little bit. 2 times d is 2d. 1 times a is a, equals t squared. Now look, I have my t squared by itself, and that's exactly what I wanted. When t squared, when a variable squared is by itself, I can now take the square root of both sides in order to get t by itself. Because remember, the square root of t squared is t. And this side doesn't simplify at all. We don't have any perfect squares under there, so we just write the square root of 2a over d equals t. Okay, perfect. So why don't you guys try the rest of these examples? We'll have the solutions up in a little bit. And go ahead and try your homework. Anytime that you can reduce a radical, you are expected to reduce that radical. All right, guys, good luck. Let us know if you need any help. Sign up for some video chats. Have a good day.